Hello everyone, my name is Harry and I was involved in the development of the Dissect Revisited website. In this video, Professor Duncan Bell will be presenting new research on iodine sublimation to enhance X-ray micro CT scans of insects, specifically bumblebees. The method shown in this video may appear simple and low-tech, but it carries potential health and safety risks. Anyone attempting it should always take the following precautions. Wear protective goggles, gloves and a mask. Whenever possible, handle iodine crystals in a fume cupboard or a well-ventilated area. Iodine vapor, like chlorine, can be irritating to the eyes, nose and respiratory system. We strongly recommend this procedure is only carried out in a professional setting using proper safety precautions.
Hello. In this video, the intention is to show a few slides and make a demonstration of looking at the different adult bumblebee casts before and after staining them with iodine and then performing micro CT. So here is a typical worker bumblebee. We scanned her and then put her in an airtight bottle exposed to iodine crystals. We looked at her at 7, 14 and 21 days after being in iodine. Now this is the 3D scan before the iodine. Although you can see quite good anatomical detail of, let's say, the antennae or the ocelli or whatever, this bumblebee is noticeably naked. We cannot see her bristles. The other problem was that when we cut into the middle of her, and I'm going to concentrate here on the abdomen, you could see that she had a reasonably large abdominal air sac, but we really couldn't see much detail of her crop, her midgut, her hindgut, etc. We could see the tracheal system, the air sacs. We could see inside the sting recess, but unfortunately there was very little in the way of X-ray differences in attenuation of soft tissues. Now the usual method to do this is to use something like Lugol's iodine or 1% iodine in 100% ethanol. We have been experimenting instead, as I've said, using sublime iodine. Iodine goes from the solid to the vapor stage. After 1 week in iodine, now you can begin to see the typical bristles on her. We were much more interested in looking inside her to see whether we could now see better details. You can see that within the abdomen we were already beginning to see more at 7 days. We get even better staining at 21, but we want to see how well she is stained internally. You can now see on the 2D views, we can see good detail. Let's look inside her. So now we're in the midline and the petiole, but we're not quite in the midline in the sting recess. Now we can very obviously see esophagus in the thorax passing through the PTO. This area here is her crop, her honey sac, and in a moment, if we cut in and out, we'll see the shape of the proventricular valve, which runs obviously from her crop, her honey sac, into the mid-gut, often known as the stomach confusingly, or volvulus. So if I cut back and forward, hopefully we should see the proventricular valve there. There's the bit within the crop. There's the bit within the volvulus. The shape of the bumblebee proventricular valve is different, as you'll see in the female casts and the drones, but more of that in a moment. I think we can nicely see the large lumen there of the midgut. Perhaps we'll get a better view if we come out and look from on top. Large abdominal air sac. We've already seen the midgut, and we want now really to see whether we can see the hind gut, the anterior intestine, which, as you'll see, is only about 1/4 of the diameter of the midgut, but has relatively thick muscle layers and shows up very white, very radio opaque. Crop, proventricular valve, ventriculus, anterior small intestine, in other words, the midgut. Now, in order to trace back from the anus and rectum within the sting recess to where it joins the hindgut, so I'm now going on to look at a gyne. We can first of all see the heart. We can see the ventral diaphragm, below which we can make out the ventral nerve cord, and above the dorsal diaphragm you'll see in the moment the heart. In the worker wasp we already could see the crop, which is this structure here, and in a moment again, as I cut in and out, we'll see the proventricular valve. So here is the hot cross bun view, and running in and out we see the whole of the valve from running in and out. So now we're seeing the anterior intestine, and at the moment we're not quite sure what this area here is. It's obviously black, it's low intensity, but not as low as, for instance, air outside or air within the air sacs, but we'll be looking at that in a moment. What we want to see now, we've seen where the proventricular valve drains into the ventriculus. I would like to see if we can see where the hindgut joins the midgut, because at that point we should be able to see the Malpighian tubules, and also see where the hindgut joins the lower hindgut, in other words the rectal pouch and rectum. So as we cut in, we're mainly seeing anterior intestine here. We're still seeing this area here of low intensity. I'd like to try to convince you that this is where the hindgut joins the midgut, and if we hone in on this area here, we should, with a bit of luck, start to see the Malpighian tubules. It's very difficult to follow the small intestine because you'll see it wiggles all over the place. You can see it again at the bottom, if I cut in there, because within the sting recess one can see the anus, one can see the gonopore and the vagina, the sting recess and the bursa copulix, but where exactly the hindgut joins onto the rectum, as you'll see, is a little bit tricky. This female, whether she's mated with one of her brothers or not in the absence of the queen, certainly has some ovariolar tissue. You can see some material here. You'll see in a moment if I cut in and out. Yeah, this structure running here seems to be 4 ovarioles on each side, and you'll see in a moment them draining into their respective left and right ducts. If I turn this round and looked at her from the other side, we should see a similar structure. We can see there's some eggs here. We can see vaguely the ovarioles behind the midgut. It's this structure here. So there's the sting and the sting recess. These are the right and left oviducts draining into the common oviduct and draining here into the back of the vagina. I now want to look at a male. This is a drone, a male bumblebee, after some 21 days in iodine. Externally we can see rather better staining of the bristles. We can also see reasonably good staining of the male genitalia within the gonopore, but if we turn the specimen around, we can see a lot better. Perhaps we should just go back to the specimen before staining. Again, you can see the external genitalia quite nicely. One can just about make out that this drone has a large crop growing in and out. One can see actually quite nicely the whole of the male genital system. How much better will we see it looking inside? Now we can make out the air sac. This great big thing here is all honey sac. The bit here is midgut, and obviously the bit here is the very impressive endophallus and endophallus. We had already said that the proventricular valve draining from the crop into the midgut is a very different shape in a bumblebee from the female, and I'll draw round it. All of that is a very chunky valve, which is a very different shape from that seen in the workers, gynes and queens. The only other feature is looking at the ecto and endo parts of the phallus, because obviously there is air between the structures in the same way there's air between the sting and the sting recess. You can get more details of the shape and function of the phallus in the bumblebee. So, in summary, with iodine staining we can get much better staining and preserve, for instance, the air sacs and tracheal system.
In this video, we have concentrated exclusively on the abdomen. For a more in-depth look at the brain, please go to the Dissect Revisited website and check out our latest PDF. Thank you.